Obrigado, thank you. Hello, I am Andrew. My Portuguese is terrible, so I'm speaking in English. This talk is about channels, and not just about channels, but about more than that. So let me start with who I am, if you're not familiar from the introduction. So I am a core developer on Django, the Python web framework. I'm also a senior software engineer at a company called EventTlit. If you're not familiar, we do ticketing and that kind of stuff. I'm getting some good thumbs up from the audience, I assume that's good. And I am probably most well known for working on stuff in Django. So South, Django migrations, and also channels, my most recent project. And this talk initially was going to be a bit about like what is channels, but I've done that before. And so I want to try a different kind of talk. And this talk is more about something else. Why is channels like it is? Like, what is my thinking? Like, how did I design it? Why did I do what I did? So to start with this, I want to take you through a history of what has happened in Python around things that channels deals with around the web, and also around things like running threads and concurrent code, things running in parallel. So the story starts back in around the year 2000. This is before I did Python. I started Python around 2005. But back in 2000, we have Python is still version 1, not even a 2 yet. And the threading module is introduced in Python 1.5. This is the first way to write threads in Python. You can write 2 threads side by side that do the work apparently at once, but it's kind of a lie. It's not really threading. All it is it's just taking those 2 pieces of code and switching between them on the same processor. It's no faster than doing the same thing in one thread. And so what it's really for is stuff that waits on disks or on the network that's particularly slow. And it's fine, and for 2000 it's particularly decent. But the problem is it's not very easy to use, and as I'll show you later, it's quite dangerous. Shortly after this, in 2002, Twisted has its first major stable release. Now, if you don't know about Twisted, Twisted was for a long time, and probably still is, the single biggest and most popular networking part of Python. It lets you write things for web servers, for emails, for games. I used to write a Minecraft server in Python, so it's with Twisted, it's very useful in general. And so it's pretty versatile, and it's been around for a long time. It's what? 15 years. It's a long time. And then in 2003, we have the start of Python Web. So WSGI, or WSGI, depends who tells you what it is, first appears in 2003. The specification for a standard way of having Python code that runs websites and that our servers talk to each other. Like before this, and for a few years after this, as it sort of took a while to get everyone to use it, every server was different. Like you couldn't take your Python code from one way of deploying it and move it to like, you know, from Apache to Nginx. That wasn't possible. And so WSGI let you have this flexibility. It let you take your code and change servers as you needed. This isn't even in some other languages. Some languages you are still directly tied to the server that you start out with. So it's good for Python that's in here. Then in 2008, we're now a few years after I started doing Python. I remember this being a very big piece of news. We have the multiprocessing module. Now, multiprocessing is a little bit like the threading module, but rather than running things on one CPU core, just switching between them like different pieces of time, it actually runs them in separate processes. It launches a second Python with the same code and lets you sort of talk between them. It's very useful. It's good at doing things like data processing and science that needs lots of power. But the problem is that it's still limited. The way you talk between processes is difficult. You can only send certain things that fit under pickle. It's not particularly good, but it is a big improvement over threading for people who need it. 2008, very important. Django 1.0 is released. Django is, at this point, coming up on its 10th birthday of the 1.0 release. We had the 10th birthday for Django open source initially last year, but it's been a long time. And this is when Django really starts becoming a very big thing, like very stable. Everyone trusts it. It's very important. And of course, Django supports WSGI. That's how we say you should deploy it. And so it's part of the Python story of the web. Like you can use Django. At the same time, I think Turbo Gears was a thing, Zope as well. These are all the web frameworks of the 2008 era. All of those you could sort of deploy and switch between if you wanted to. And then 2009 is where I start getting interested in threading and parallel processing and concurrency. And this started out with a project called EventTlit. Now, you probably have heard of gEvent rather than EventTlit. They're the same basic thing. They are a different way, again, of doing threading or parallel work in Python. And the way they're different is they, rather than having 2 or 3 processes or having everything in one big thread, it has lots of, like, thousands of tiny little threads in one process. And unlike the threading module, where in threading you can just be running code and it just takes control away from you, which is at any random time, like in the middle of saving a variable, you can just go nope and give it to the other thread. This, you say, oh, well, I kind of want these things to be where I can take control away from. So you can have pieces of code that, like, this piece of code must run in one go, atomically. And so that's a big improvement for safety. And then coming to almost the present now, Python 3.4 is where we see Async IO introduced. Now, this is finally something a bit like Twisted, but changed around in the core of Python. The idea being that Python is committing to having some kind of asynchronous solution built in for everyone to use, batteries included, of course, is the Python phrase. And this, of course, becomes even more important with last year and Python 3.5, and we get the async and await keywords. And these finally let you have in Python what looks like proper asynchronous, like I can do async def and write a function. I can say await. And the nice thing here is, like with gEvent and EventTlit, you can control sort of when you yield, even better than they can, because you know that until you get to an await, you do not lose control. And so you go, oh, okay, we can go down, do all the different steps, and then, here's an await, we can release control, and a new thread can come in. Now, of course, that has some problems. I'll get to those later on, but it is a big improvement. And that's kind of where we are right now. And the other part of this is, generally, we see that the idea of handling web requests is solved. Like, we have WSGI, it's standard. Like, everyone in Python can pretty much, even if they don't do web things, understands how it works. There's a standard, you use the servers like gunicorn or WSGI, they're all there. And so this seems like, well, Andrew, why would you look at this? What's the point? And this is kind of a lie, right? It's like, sure, it's solved because it's very easy. Let me tell you how easy the web is. Every single request you get comes with everything you need. It has headers, it has cookies, it has everything else. So you can just take that request in as one big thing, process it with your Python, and forget about it. You send the response back, you're done. Your code has to live for, 100 milliseconds or a second, not very long at all. And because of this, you can have just one process just do one after the other each request. There's no need to mix them in. There's no need for threading. You can just do one request, send it off, another request, send it off. And because everything's there, you can forget everything. You can almost delete the server and start again for each request. It's very easy programming. Now, unfortunately, other protocols are not as easy as this. And there's a reason for that. But things like WebSocket, for example, which is what I'm perhaps known for with channels. What happens with WebSockets is all that information comes at the beginning, but then the socket stays open. It lives there for minutes or hours. And your server, your code, has to remember things about the socket for that entire time. So like this kind of diagram, like it connects initially, but then it might be a few hours that you're sitting there trying to keep this socket open. And You can't have one server doing one socket, or say you've got 5 servers. If 6 people connect, that's it. 6 people, it's too many. You can't do that. And why would we use this stuff? Why is it important? Well, doing this is more efficient. Because HTTP sends that information every time, it's slower. Like, you're almost wasting information if you're sending like the same headers, the same cookies every time. WebSockets and other things let us have lots of requests backs and forwards and save on that extra information. They're much lighter, much less data. And then, okay, well, that sounds good. Why don't we just write everything asynchronously? Well, that sounds like a good idea, but take it from me, I've been doing it for a while. Writing async code is really hard. There are so many problems and ways you can cause errors, or as I like to say, shoot yourself in the foot, that it just is almost a nightmare, I would say. So let's look at some of the common things that if you've done normal Python, synchronous programming, you probably don't worry about. So here are some of the things that anyone in any language who does parallel computing will know what these are. Deadlocks and live locks. These are ways that 2 threads or processes can sort of just get stuck waiting for each other. I'll look at that in a second. Race conditions. This is a case where code works when it's written by itself, but when you have 2 or 3 things going at once, very strange things happen. I have a good example of that as well. And then things like resource starvation, where it's fine when one thing wants to access a disk, but when 100 of them do, the thing falls over. So let's look at a simple example. Here is some Python. This Python does very bad bank transfers of money. So we have a dictionary called funds and 2 users. So we say, okay, user, we want to transfer from the from user to the to user a certain amount. The code checks that the from user has some money. It probably should check they have enough money, but imagine it's just, 1 real. And then it takes that from the from user and gives it to the to user. Now, anyone who's done parallel programming will find at least 5 problems with this. But the first one I will show you is the race condition. So it looks on the code like you could not possibly get inside the if without having money, right? Like, there's an if that says they have at least $1 there. How do you get through it? Well, if you run 2 things in parallel, what you can do is have both of them run the if first and then run the 2 transfers. And so what you end up with is up here, person A has $20. The if, well, that one's good. They have more than 0. That passes. This if, they still have more than 0. That's still good. And so we, in thread 1, do the transfer. We take 20 away from them and give it to B. And we have, okay, that's good. A has 0, B has 20. But this thread is still going. It's still inside this if. And so this runs as well, and now you have minus 20. And this is a classic race condition. The thing you thought you stopped, no, you did not stop it. The code is going to break on you. So let's try and fix it. Let's put some locks in. So if you don't know what locks are a way of saying only one thread can get in here at once. So you have a with statement, you say, okay, when you get to the with, one of the threads gets to go in, the other one waits for the other thread to get out first, and then it comes in again. It's a very good basic way of doing safe programming. So what we do here is we lock the funds of both users before we do the if check. That seems fine. Of course, you'd run the code, you'd get both locks, you'd run your stuff, you'd release the locks. The next thread, now the locks are released, can get them, run, done. Seems safe. Still broken. Still bad. Because this time, if the locks are taken in a certain order, you end up with, well, A, we get lock A over here. This gets lock B first. This then wants to get lock B. It can't. This has lock B. It's not possible. But it also, this wants lock A. It can't. This has lock A. And so neither of them can do anything. This is a deadlock. This is blocked. And so these are the sorts of horrible problems you have doing async programming. Like, it takes about 20 lines of code to do a simple transfer of funds safely. That's just the way this stuff works. And the more threads you have, like this is just 2. If I had 5 or 10 or 20, you're going to get more and more problems. And this is one of the things that you really don't want to have to deal with. Like, I know this mostly. I guess I am an expert at this point, but it's still difficult, right? I don't want to spend every day thinking about this stuff. And thankfully, other people much cleverer than I have thought even harder and have ways around it. So one of the things I was taught in university was a thing called CSP, which stands for Communicating Sequential Processes. It's a mouthful for me in English even. And what this is it's a way of talking about those kind of systems that have lots of pieces that move independently. But what it does, importantly, is it models small pieces of synchronous code that then talk to each other. That's the communicating part. And so we can write small pieces of code that are simple and don't run in parallel, and then say, oh, when this is finished, it sends off a message, and the other thing picks it up and runs. And this is a very good model for not only writing safe code, in fact, it is a kind of mathematics. You can take it and prove that code works, which is very strange. But it also means you don't need to have everything asynchronous. Like this kind of model is like, oh, well, you can just write small pieces of synchronous code and have them talk and work in an async manner. Now, I know it's hard to describe. I could not get enough diagrams, but trust me, the diagrams are very complicated. But the idea is, this is the idea which Channels is based on. Like, this is the sort of the inspiration I had, the way I designed this. And so what Channels is Channels is a way of having pieces of synchronous code. That is code that is written to run in a single thread, not in parallel. It's safe, it's easy, none of those weird problems happen, alongside other code that does the asynchronous stuff for you. So in Channels, like, there's a lot of complex code that takes in WebSockets, handles them, does the decryption, does all the other things you might want to do, and keeps them alive. That runs over in one place, and all your code runs somewhere else synchronously. So you don't have to worry about things like decryption or keeping it alive. You just write simple Python that handles it for you. It's very, very hard to make a mistake, and that's what I like in a framework. I think Django's job in some way, and a framework in general, their job is to help you not make mistakes until you want to. Like, you can always choose to just remove the framework and make mistakes. That's your choice. But our job as a framework is to make it very difficult for you to do that until, like, when you feel confident, you go, okay, I now think I'm an expert, knock away the framework, everything collapses. It's your fault, not ours. So this also is interesting for WSGI. Now, if you're not familiar, and I'm sure most of you are, WSGI, the standard for web in Python, is very simple. It is literally a function, a callable, that you give a request to and returns a response. That's basically the entire specification. There's a bit more about like what you give it and what it returns, but you can write a WSGI application in like a few lines of code very easily from scratch. And the problem with that is that a single callable is not enough for a socket, because the way it's designed, it would have to call the function and just block, like we saw before, for like hours or minutes until the socket closed. And so the other part of my task is to try and invent a new version of WSGI, which I call ASGI, because I'm not very inventive, that sort of handles that gives you the extra flexibility you need to handle asynchronous stuff. And this has actually changed a bit, as I'll tell you in a second. But my main goal for, Channels and people in general is to have you only write synchronous code if you want to. As I said, I do not want to write complex async code. I find it difficult, I make mistakes, and it's nearly always not needed. There are very few things where you need async. Those are fine, use it there. There are many, many other things where you do not need it. And so I'll show you a brief example. This is sort of what channels looks like if you're not familiar. What you do is we take a socket or other thing that has events, and we make it into a series of events. So like you don't write code that like waits on a thing. You say, okay, when something connects, then do this. Like I can set a username variable, you know, and then you return control. It just goes back to doing whatever stuff. Your code isn't running. And then someone sends a message over the socket. Go, oh, I'm going to call your code again and give you the message. And then, okay, and then you can do some stuff in Django here in one thread and then return again. But like nowhere here is there async stuff. This all runs in a single synchronous thread. So it's pretty good. The obvious question, Andrew, why don't you just use Async IO? It's in Python now. That's a good question, me. There are two reasons. The first reason is I started this 3 years ago, and Async IO wasn't there. That's a bad excuse. It's my excuse. The second reason is Python 2.7 support. Django still runs on Python 2.7. At least the LTS does. So Django 1.11, which was released, I think, last year, is supported for 3 years. And for those 3 years, Django will support Python 2. Django 2.0, which comes out very soon, Python 3 only. And so Django is on that edge of 2 and 3. And when I started this 2-3 years ago, it was far enough back I wanted to do Python 2. These days, though, I don't know, like Python 3 is so much nicer. If any of you have written in Python 3, especially with async and await, the code is much easier to read. It looks a lot more like Python. It is harder to make mistakes. And so my feelings have changed. And these days I feel like, yes, Andrew, you should probably use Async IO. And so right now I'm in the middle of doing that transition. So thinking about Channels 1, Channels 1 is the version you can use today with Django. It's released. It's running in production in many places. But it's quite limited. All you can do is write code, as you saw a few slides back here, that is synchronous. You can't really do anything else. And it also runs in a weird way. It runs using some twisted, some async IO, some threading, a couple of extra processes, and some Redis. If you're confused, good. It's very confusing. And this is just too much. Like, I like simple systems. I'm a big fan of things that are easy to understand, because as a developer, as an engineer, your job is to understand what the system you are working on does. Like, what are the guarantees it gives you? How is it designed? And so my goal with Channels 2 is to make it much simpler. So, for example, in Channels 1, the thing that takes socket connections, which is called Daphne, is a separate process to where your Django code runs, just separate. And what they do is they talk over a Redis server in the middle. Now, this is good because it means you can have this process that does the sockets and all that kind of stuff, and all the sort of networking is all asynchronous. It's all twisted in this case. And you can have the other server, the other process, be all synchronous. That's just Django in a big while loop that goes round and round and round and says, okay, run Django, handle a message, come back, handle a message. That's very good for separation, but it's very confusing. And it means to even make it run on your laptop, you now need to run 3 things. And I hate when things are hard to run in development on a laptop. And so what Channels 2 does is it uses a lot of new things in Python 3 to get around that. So crucially, everything runs in the same process now. There is an Async IO core that handles networking and sockets, all those kinds of things. And that then has, sitting next to it, some threads. And those threads are synchronous. And so if a message comes in, the async code handles it and works out what the bytes mean and decodes it and does all the encodings, gets a basic message object like a dictionary, and passes it to a thread. In that thread is synchronous Django. But crucially, it doesn't have to be synchronous Django. What you can do is you can also write a handler, a function, that is asynchronous. And that abstraction I talked about with WSGI, that it is a function that calls, that is sort of the same. I have now like, oh, it's a function that gets called with a thing you can await on to get events. And so what actually happens is Django is a synchronous function wrapped in a thing that does threading and asynchrony around it. And this means if you want to, you can have a middle ground. So before channels 1, you have the easy route, which is synchronous code, all done for you, all through Django, or you have the very hard route, which is, well, you have to throw everything away and just use raw asynchronous code. I like middle grounds, so channels 2 has the middle ground where you have some safety. You can use all of our code that does the HTTP and WebSocket termination. You can have all the safety and some of the Django features, but you can also write things that do awaits or requests with Async IO's requests libraries, and it all works properly. And so that's kind of my goal, is to have this mixed thing where you can write the things that have to be asynchronous in the asynchronous side, and the things that don't have to be, as you always did, in a nice, easy, synchronous way. Like imagine you had a page that, oh, this page calls 20 other websites to get results. That should be asynchronous. It should take the 20 things, run all the requests in parallel using Async IO, bring them all back, and give you the result. But if I have another page that does like the user login, I don't want to have to deal with that. So that's a normal Django login. But crucially, and this is important to think about, and took me a while when I was making stuff for Django, it doesn't solve everything. And often people come to me and say, Andrew, why doesn't Django do this thing? They think of something and tell me about it. It's always different. I'm like, well, Django's job is not to solve everything. It's to solve 90%. Like to make nearly all of your life easy and then leave you with the one special piece that's only your problem. Because we all have different sites and projects we work on, and they all have something that's a little bit different. And our job is to let you only work on the different thing and leave all the things that are the same, the common things, up to us. And Channels is the same. Like Channels' job is to give you the stuff that's really hard and is always the same, like, oh, here is the code that takes a socket, and WebSockets are ridiculous, by the way. The specification is awful, but we handle all of the weird encryption and the byte handling and the encoding for you and give you a nice interface. If you want to then write a chat application or a live blog, that's your part to write. Like I can't ship a fully functional chat server and a live blog server and a thing that does live graphs and a game engine. Like that's not a framework's job. It's to do the common stuff. And so Django's job and Channel's job is to try and solve the common case. But even with that, there is a way to look beyond this. Often people, when they hear about Channels, they hear about WebSockets. They think, oh yes, Channels is the way to give Django WebSockets. It's my fault. I used that as the advertising for a long time, but my goal has always been more than that. I think that the web and the internet in general is moving beyond HTTP, right? We have other protocols. We have WebSockets, we have emails, we have chats like Telegram and WhatsApp, we have SMS, we have lots of things. And these are all ways you can interact with the site. In Africa, for example, SMS is a very, very widely used way of doing banking and other things because SMS, everyone has it, but they don't have good internet or data. And so how do we build a system that handles not just HTTP, but all these other things as well? Like, how do we make Django that thing? Should that be Django? Like, and this is a question that I think about a lot. Other people on the Django core team also think about a lot. And we don't really all agree. The secret of Django is that none of us ever agree on everything. But enough of us do that stuff gets done. There are, I think, 50 core team members, and 50 is a lot of people. And so the question really is, what is Django? Like, is there a goal? Like, should Django, we're at version 2.0 now. It's been stable for a long time. Django is trusted by banks, by governments. Like, it's very boring in a good way. People like Django. But like, should we be happy with that? Should we stop and go, we're done, dust our hands off, hang up our hat and walk out the door? I don't think so. I think Django is about a way of thinking, a way of programming. And I think we can do things in the Django philosophy, as it were, for other things. Like, we can let you write an SMS handler with Django views and Django models. We can let you have something that, like, you can send emails to your Django site and write something that handles the emails in the same place you do things like web requests. And this is all kind of part of a bigger push of making asynchronous code easier. A lot of people these days, when they think, oh, I want to write async code, what should I use? They often don't think Python. You think JavaScript or Node.js. You think of Go, the language. There are many other options. And Python is certainly as good as JavaScript. JavaScript is also the same kind of threading as Python. And so it is my goal to try and make Django or Python have a better way of writing this kind of code, not only faster, because the Python way is to write quickly, but also well. Like, if you write Python code, it's pretty hard to, have errors or, as I said, shoot yourself in the foot. And so I really want to try and make Python the best place for this kind of programming. Like, how do we foster a community like we did back in 2003, 2008 with Django and WSGI? Is there a way to take Python to this next step? Like, have it be the language of choice for handling all communications via everything people interact with to all of these systems? And I'm very aware it may not end up being Django. A lot of people think of Django as now like, oh, it's the old man, right? It's the elderly, happy person who sits in the corner and everything's fine, but it's not very exciting. And that's kind of true. And I and some other core team members do take pride. We like that it's called boring and not exciting, because you don't write governments on exciting software. You write governments on boring software. But at the end of the day, I like Django and I like Python, but like, I want to have Python be the best place. It may be that my work in Django doesn't end up being used, but I hope that what happens is, if it's not what I do, I inspire somebody else or other solutions, and it's the catalyst for that kind of change. And I think at the end of the day, making Python the place to turn to for asynchronous programming, parallel programming, making these big systems, I think that's my goal. And with that, thank you.
Vamos lá, então. Perguntas? Vamos começar aqui. Já o segundo, já alguém que tem interesse em perguntas?
Hello. Hey, Andrew.
English? Okay.
Yes. It's not a question, actually. I'm work with Django like for 10 years. And a lot of things make me continue with Django and not move to another framework, like admin, models, or AM. But two things were really good. It was Self and Django migration. And I just want to thank you for that, because it saved a lot of time for me and a lot of people here too, I think.
You're welcome.
Mais alguém? Vamos lá primeiro e...
Hi. Yeah, I don't work with Django. I have worked in the past. And currently I'm using Socket IO with Flask framework. And I just want to know why your channel solution is not using Socket IO for WebSockets. If you have something to share about the Socket IO and channels parallel. Yeah. That's it.
Yeah, that's a very good question. So the main reason is Socket IO is not just WebSockets. It is WebSockets plus a long polling solution that sort of, if the sockets don't work, if there's like a bad server in the way, falls back to other stuff. The problem is the way Socket IO is designed is very hard to scale. Like the specification basically you need a single database that every server can see to share information. The system I have made naturally can't do that because it scales. And so like, I do want to make a thing that lets you put Socket IO into channels. It's very possible. It would happily work. I just need to find the time. But the reason I went not in the first place is because it has some problems that I wanted to go pure WebSocket because that's easier for me to work with.
You cited Node.js, and many people that work with that doesn't know that it works just like Twisted and just like Django. And what you from the core team think about that in the marketing way? It got a lot of fame. Python is much better than JavaScript. Do you think that this is some kind of not a menace, but do you think that we could have presented Python and Django better and had gathered more people to the community? Why Node.js got so?
So I think we still can. I disagree that Python is better than JavaScript. I am very diplomatic. What I will say is that like we could like what JavaScript has done, and Node in particular, like Node was this big revolution in terms of it's fast, it has a certain kind of compiler, the JIT, the JIT, and that really made things better. And I think Python's job is to come along as the sort of sensible helper. Like I said, like Python is what, 20, 25 years old now. Python is almost as old as Java. It's very old. And it's old enough that like, you know, banks like it, and banks are very bad at new languages. And so I think the thing to push is how can we take that part of Python and advertise that along with like this kind of thing. Like, you know, oh, we have a stable community, we have all these packages, it's been around for a long time. And more than that, like some people say that advertising is not part of open source. I disagree. I think it's very important that open source projects are good at advertising and marketing themselves because code is only good if someone uses it. And it's a big part of like, how do you present yourself? The Python community, and I've met many parts of the community here and around the world, are amazing people. And like we can use the people, we can use all of the things about Python and this kind of stuff too. I think there's still a good time to build that story. And what it needs, I think, is almost like a special example, like a site or a project that goes big, that uses Python. And hopefully the work I'm doing can help that happen.
Mais alguém? Não?
Oh.
Hi. I'd like to understand how do you manage your work between EventTlit and working Django core?
That's a good question as well. It can be a big problem with open source to find time for open source. So I am very lucky. EventTlit gives me 1 day a week to work on Django entirely. So I spend 4 days a week at EventTlit working on all this. We have a lot of code, so much code. And 1 day a week working on channels. And often like that's 1 day, Monday to Friday, and also some of my weekend as well. It can be difficult, like if I spend a whole weekend and then the week and then the other weekend, I can get burnt out, right? I can get, yeah, like generally I get some good time. And also EventTlit uses some of the channels code inside. In fact, channels comes from EventTlit research we did into this kind of area 2 or 3 years ago. Like the choice of Redis, for example, is based on that. So there is some shared work there, but ultimately, obviously, everyone would like to write Django full time, but finding the money for that is difficult. So I'm very glad that right now I have that 1 day a week to work on it.
Hello, Andrew. Continue with the previous question. That you're telling us the case of EventTlit, but how do you think that it's a good solution for other free software development? Because it's been like a very popular topic right now, because there are many projects that are just done or maintained by just one person, and this person does it in their free time, right?
Yes.
So do you think how we convince companies, or how we convince other people to join this project? Because I think it's not about money nowadays, it's about time in many sense of this. So that's the question.
So a couple of things. First of all, in some ways, money is time. If someone appeared out of nowhere and gave me $1 million, I would have a lot of time to work on Django. So in that sense, money is time. That's not going to happen, though. But the other thing, like, it is a problem, and I am not qualified, nor do I have like the 3 hours to describe all the different kinds of open source funding. I do think there is a problem. As you said, there are some projects, I think famously SSL for a long time was 2 people. The whole internet runs SSL, 2 people. And then one of them got ill. So at that point, you are literally like one illness away from the internet not working. And a lot of this is hidden, right? You don't realize until you look like how few people work on things. Like Django, we are very lucky to have somebody, Tim Graham, employed full-time who does bugs and basic fixes and security patches. Many projects do not have that, and it's a big problem. Part of it is a cultural change, I think, like making companies more aware of the stuff they depend on, maybe framing it as risk in terms of like shares or to shareholders. And part of it also is making it easier to give money to the stuff you use. I'm not sure how that is. There's been some conversation just this week about like donations are very hard to do from companies, but purchases are easy. Like I can go and, well, I can't, but like, you know, someone can just go and buy a new editor because they need to do their job. Like that's a purchase. But donating $100 to a project, even though it's the same amount of money and it's probably more useful, is seen as very different. I think framing that differently, and I have many ideas. Like of course, if people aren't aware, I kickstarted Django migrations. Like I did a big Kickstarter. I asked for funding. I asked for £2,500, which is around, let's say, 9,000 real, I think. I got over 10 times that, which is very nice. For a whole year, I worked on migrations. That does not work for everyone. And so I'm not sure what the answer is, but I'm hoping, like with all the talk, I think we're getting closer to finding a good solution. And hopefully we'll get there.
Acho que é a última pergunta aqui.
Thank you. This is awesome, Andrew. You mentioned that maybe the solution is not going to be something called Django. So you envision maybe a way, I would like to ask whether you envision a product that may be completely independent, such as, for instance, something that I want to use channels to do MQTT work or a game server, and then I wouldn't have anything of Django in it. Is that what you're thinking?
Yeah, so that's one part. And so like when I talk about changing WSGI to ASGI, part of that is having that thing again where you can use different parts of Python packages with each other. So like, oh, here is an MQTT server talking to a Flask app, right? Like you can swap around. But that is my vision. Obviously, I do not commit to Flask or GUnicorn or WSGI, but like I have been talking with some of them, and my hope is that we can all have a system where, again, you can swap pieces around and have that work. But yeah, like I think Django is big enough we can lead the way. Like Django has the momentum that like if we say we're doing something, people will at least notice. And it's how do we use that for good? How do we, because like Django is one of the reasons WSGI exists in the first place. Like we adopted it, that really helped the adoption. It's obviously not the full story, but how do we use that again and try and be the pioneers, I guess is the English word, in the field for that stuff.
Thank you, Andrew.
Thank you.